Look at your hand. Go ahead. Really look at it. Now press it against the table in front of you. Feel that? That resistance. That solidity. That feeling is a lie. Not a small lie. Not a simplification. A complete, profound, beautiful lie that your brain has been telling you since the moment you were born. Your hand isn't touching that table. It never has. It never will. And in the next 22 minutes, I'm going to dismantle everything you think you know about the physical world. We're going to go deep, past the comfortable fictions they taught you in school, past the neat little diagrams of atoms with electrons orbiting like planets, because reality is so much stranger than that. Here's the first crack in the illusion. Your hand right now is 99.9999999% empty space. Think about that percentage. If an atom were the size of a football stadium, the nucleus would be a marble at the center. The electrons? Invisible specks orbiting somewhere in the nosebleed seats. Everything else? Void. You are almost entirely nothing. The table? Same thing. Empty. The air between you and the screen you're watching this on? Empty. So here's the question that should be keeping you up at night. If you're basically empty space, and the table is basically empty space, why doesn't your hand just slip right through it? Why do you feel anything at all? The answer they gave you in school, that your atoms are bumping into the table's atoms like little billiard balls, is wrong. Completely. Utterly wrong. There are no billiard balls. Let's talk about the biggest lie in your high school chemistry textbook. You remember the picture, the atom. On a nucleus in the center, protons and neutrons huddled together like a tiny sun. And orbiting around it, little electrons following neat circular paths, like planets in a miniature solar system. The Bohr model. It's beautiful, it's simple, it's clean. It's fiction. Those orbits don't exist. Electrons don't orbit. They don't move in paths at all in any way you can visualize. When physicists try to track an electron's position and momentum simultaneously, nature itself says no. Not because our instruments aren't good enough, because the question itself is meaningless. An electron doesn't have a definite position and momentum at the same time. So, if it's not a little ball, and it's not orbiting, what is it? Here's where we leave the comfortable world behind. An electron isn't a thing at all. Forget particles. Completely erase them from your mind. The universe isn't made of tiny pieces of stuff. The universe is made of fields. What's a field? Think of the surface of an ocean. It's everywhere. It fills all of space. Now imagine someone drops a stone into that ocean. What happens? A wave ripples outward. That wave, that disturbance in the water, that's what we call a particle. But here's the critical part. The water was already there. The ocean existed before the wave. The wave is just a temporary excitation, a little bit of extra energy concentrated in one spot, moving through the medium that was always present. Now here's the mind-bending part. Everything works this way. There is an electron field. It permeates all of space, every cubic centimeter of the universe, right now. When that field vibrates in a particular way, we see an electron. The electron isn't a thing traveling through space. It's a ripple in a field that's everywhere. There is a quark field, same deal. Up quarks, down quarks. Each one is its own field, filling all of reality. Photons? Vibrations in the electromagnetic field. You, me, the table, the stars, we're all just different patterns of vibration in these underlying fields. Let me give you a better analogy. Imagine a guitar string. When you pluck it, it vibrates. That vibration creates sound, a note. Now, where is that note? Is it a thing you can point to? No. It's a pattern, a frequency, a mode of vibration in the string. Different vibrations give you different notes, but it's the same string. The universe works exactly like this. The fields are the strings. The particles we detect, electrons, quarks, photons, those are the notes. different vibrations in the underlying field. When you see an electron in a physics experiment, you're not seeing a tiny ball. You're detecting a vibration in the electron field that happens to have a very specific frequency, a specific energy. And here's the part that breaks most people's brains. The field is more fundamental than the particle. The particle is temporary. The field is eternal. Before the Big Bang, the fields were there, silent, unvibrating. After the heat death of the universe, the fields will still be there, return to stillness. Everything you think of as matter is just temporary music played on permanent instruments. Now we can answer the real question. When you press your hand against the table, what's actually happening? The electron fields in the atoms of your hand are getting close to the electron fields in the atoms of the table. And electron fields really don't like to occupy the same space when they're in the same quantum state. This isn't a choice. It's not a preference. It's a law of nature called the Pauli exclusion principle. When those fields get too close, they create a repulsive force, not because particles are bouncing off each other. There are no particles, because the fields themselves are interacting. That feeling of solidity? That's electromagnetic field repulsion. It's one field screaming at another field, "You cannot be here. You've never touched anything in your life. You've felt field repulsion your entire existence and mistaken it for contact. The floor beneath your feet? You're hovering above it. Suspended by quantum field interactions, floating on an electromagnetic cushion so thin you can't measure it. You are not standing on solid ground. You are levitating. Now let's go deeper. Let's talk about what you are. Your body contains approximately 7 octillion atoms. That's a 7 with 27 zeros after it. Every single one of those atoms is made of quarks and electrons, which, as we now know, aren't things. They're vibrations in quantum fields. So, what are you? You are a stupendously complex pattern of vibrations in multiple overlapping quantum fields. The quark fields are vibrating in configurations we call protons and neutrons. The electron field is vibrating around those configurations. The electromagnetic field is mediating the interactions between them. You are a symphony, a temporary arrangement of waves in a cosmic ocean. But here's the existential twist. If you're just a pattern, just a vibration, what makes you you? What makes you feel continuous, permanent, solid? The answer is energy conservation. Think about a whirlpool in a river. The water molecules that make up the whirlpool are constantly changing. New water flows in, old water flows out. 5 minutes later, not a single molecule is the same. But the pattern persists. The whirlpool maintains its shape, its structure. Why? Because the energy of the flowing water creates and maintains that stable pattern. You work the same way. The atoms in your body are being replaced constantly. The cells in your stomach lining are replaced every few days. Your skeleton is completely rebuilt every decade. Even the atoms themselves, through metabolic processes, are swapped out for new ones, but the pattern persists. The information encoded in your DNA keeps rebuilding the same structure. The electrical patterns in your brain, your memories, your personality, your sense of self. Those patterns remain stable even as the physical substrate changes. You are not your atoms. You are the pattern those atoms are arranged in. You are a wave that has learned to perpetuate itself. And here's where it gets truly unsettling. Those quantum fields we talked about, they're never completely still. Even in what we call empty space, the vacuum, the fields are constantly fluctuating. Virtual particles pop into existence and annihilate back into nothing thousands of times per second in every cubic centimeter of space. The vacuum isn't empty. It's boiling with quantum activity. We call this the quantum foam, the fundamental fabric of space-time. When you look close enough, is roiling, turbulent, alive with temporary vibrations that flash into existence and vanish before you can measure them. You are floating in this foam. You are made of slightly more permanent versions of these same fluctuations. The boundary between you and not you is far blurrier than you ever imagined. So let's put this all together. Solidity, an illusion created by field repulsion. Particles, temporary vibrations in eternal fields. Emptiness doesn't exist. Even the vacuum is full of quantum activity. You? A stable pattern of waves in an ocean of quantum fields, maintained by energy, rebuilt constantly, persisting not because you're made of permanent stuff, but because the pattern knows how to copy itself. The void isn't empty. It never was. The universe isn't made of things separated by nothingness. It's made of overlapping fields, vibrating together, interacting, creating everything we call reality through their interference patterns. We're not rocks floating in an empty void. We're waves in an infinite ocean. And here's the beautiful part, the part that makes this more than just physics. If we're all vibrations in the same underlying fields, then we're not separate. Not really. The electron field that's vibrating to create the electrons in your brain is the same field vibrating to create the electrons in the stars. The same field, one continuous medium, expressing itself as countless temporary patterns. Every atom in your body was forged in the heart of a dying star billions of years ago. But it's deeper than that. Those atoms aren't even the fundamental thing. The fundamental thing is the field. And that field connects you to everything. When you look at another person, you're not seeing a separate thing. You're seeing a different vibration pattern in the same quantum ocean, a different song being played on the same cosmic instrument. The boundaries we perceive, where you end and the world begins, those are useful fictions your brain creates to help you navigate reality. But they're not fundamental. At the deepest level we can currently measure, there is only the field, only the ocean, only the music. And you are a note in that music that has become complex enough to listen to itself. So look at your hand one more time. It's not solid. It never was. It's a ghost, a pattern of quantum field vibrations, held together by forces you can't see, floating above surfaces you'll never actually touch. But here's the thing. That doesn't make it less real. It makes it more real, because now you know what it actually is. Not a simple lump of matter, but a magnificent, temporary, impossibly complex arrangement of the fundamental fabric of reality itself. You are not a thing in the universe. You are a way the universe is vibrating right now. And for this brief moment, these few decades you have, before the pattern dissolves back into the quantum foam, you get to be a part of the universe that can understand itself. Solidity is an illusion, but the wonder, the connection, the music, that's real.